electromagnetic fields. The Kabbalists reference those same traditions that Manly P. Hall was talking about with the Egyptians and stuff using staffs and wands with the electromagnetic fields. The Kabbalists reference many of those same practices, and many of these other esoteric traditions do. So explicitly, there is a Kabbalistic model and interpretive framework for electricity and electromagnetic fields. We're not going into big detail on this chapter, but they discuss the gematria number associated with creation and Adam Kadmon and the Moshiach, their Messiah. They all have gematria numbers associated with them, and these can be potentially interpreted with different frequencies. Again, you can see where I'm headed with this, but before I go too woo-woo with this stuff, let's look at the actual scientific studies on some of these specific electromagnetic frequencies that we're talking about here, because I want you to have an understanding of where I'm trying to take this stuff and why it matters above and beyond speculative, why it matters in the real world when I'm talking about, well, there's all these deceptive practices and electromagnetic fields fit in, but where's the practical application part? Well, let's demonstrate that.
So now where I'm going to start to tie this together with the actual direct sciences. We have terahertz radiation, also known as sub-millimeter radiation, terahertz wave, tremendously high frequency, T-rays, T-waves, T-light, T-lux, or THZ, consists of electromagnetic waves within the ITU designated band of frequencies from 0.3 to 3 terahertz, although the upper boundary is somewhat arbitrary and is considered by some sources as 30 terahertz. 1 terahertz is 10 to the 12th power of hertz, or 1,000 gigahertz. So whenever we were referencing 5G frequencies, we were primarily referencing gigahertz frequencies. And so this is anywhere from, and so this is 1,000 times that when we're referencing terahertz frequencies. Wavelengths correspond to ranges from 1 millimeter to 0.1 millimeter because terahertz radiation begins at a wavelength of around 1 millimeter and proceeds to shorter wavelengths. It is sometimes known as the sub-millimeter band. This band is associated with microwave and far infrared and can be regarded as either. Compared to lower radio frequencies, terahertz radiation is strongly absorbed by the gases of the atmosphere, and in the air most of the energy is attenuated within a few meters, so it is not practical for long-distance terrestrial radio communication. However, there are frequency windows in Earth's atmosphere where terahertz radiation could propagate up to 1 kilometer or even longer, depending on atmospheric conditions. It can penetrate thin layers of materials but is blocked by thicker objects. Terahertz beams transmitted through materials can be used for material characterization, layer inspection, relief measurement, and as a low-energy alternative to X-rays for producing high-resolution images of interior solid objects. Terahertz radiation occupies a middle ground where the ranges of microwave and infrared light waves overlap, known as the terahertz gap. It is called a gap because the technology for its generation and manipulation is still in its infancy, or not well understood. The generation and modulation of electromagnetic waves in the frequency range ceases to be possible by the conventional electronic devices used to generate radio waves and microwaves, requiring the development of new devices and techniques. Meaning what? There is a gap from what we can produce in our machines that generate gigahertz frequencies to get to the terahertz level. So they need a more conductive material. We'll get there. So the description, terahertz radiation falls between infrared and microwave in the spectrum, shares properties with each of these, etc., etc. Terahertz radiation travels in a line of sight and is non-ionizing. So this is their code for don't worry, it's not dangerous. Go back and reference my previous electromagnetic field lectures where I discuss neurasthenia, Spanish flu, 5G, and COVID. For more details on that, we've had decades in this literature for an extended period of time, and there's an active fight to try and suppress that information that we stated simply as fact decades ago, and now they generate studies under specific conditions with specific parameters that generate the results that they want, which say, don't worry, it's not dangerous. And I compared and contrasted those in those previous lectures. So you can go back and reference those if you have questions about that. Now, the truth about terahertz. Anyone hoping to exploit this promising region of the electromagnetic spectrum must confront its very daunting physics. Not much has changed in the last 10 to 15 years, says Peter H. Siegel, highlight last name because we know who that is or what tribe they belong to, was a founding editor-in-chief at IEEE Transactions on Terahertz Sciences and Technology and the Journal of Microwaves. One of the editors of the Journal on Microwaves belongs to the tribe, if you don't know the etymology of the last name Siegel. So just FYI about why you might have trouble researching this. The research science realm has, as opposed to actual commercial applications, and is still equally divided between optical and microwave techniques, radio upconverting. A senior research scientist at California Institute of Technology with the Jet Propulsion Laboratory, the applications that were hyped in those days were from people who didn't really understand the field at all and were treating it as if it were some magic new device or frequency that could do things it really never could do. Everybody in the field knew it couldn't do those things. The applications of terahertz is actually being used to include long-time staples such as molecular line spectroscopy and astrophysics, earth science and planet science, to study quantum effects. Again, there's problems with the quantum model, but we'll continue on, including anything researchers want to know about molecular motions and how molecules interact. It will remain a key application, I think, forever because paired to the energy levels and scales at which the phenomenon occurs, terahertz is the only frequency where you get the information about molecular interactions that tell you all about quantum states, temperature, pressure, fingerprinting, etc., but it all has to be done at low pressure. So in other words, this is ideal for getting a lot of interesting data from their standpoint. Because the wavelengths are so small, the data point that you get from that wavelength interacting or hitting something is much larger. You get more data because the spaces between the data points is smaller. You can think of it like a higher resolution image, more on that later. Narrowly focused beam transmits signals over short distances, say a few hundred meters at most, and you can do it without having to get FCC approval for operation in a band which iOS already overcommitted. It's niche, but you'll see a lot of paper on that these days in terahertz journals. Wirelessly transferring huge files in the blink of an eye, detect bombs, poison gas, and clouds, and concealed weapons from afar, peer through walls with T-ray vision. You can do all of it with terahertz technology, or so you might believe after perusing popular accounts of the subject. The truth is a bit more nuanced. The terahertz regime is promising yet vexing slice of the spectrum, lies between the microwave and optical. This radiation does have some uniquely attractive qualities. For example, it can yield extremely high resolution images, move vast amounts of data quickly. So you think of what we've been promised with 5G, because if you've noticed, your data is not that much faster, is it, after this supposed exponential boost in how fast everything was supposed to be transmitted. And yet my cell service is just as slow as it ever was. My internet's just perhaps even slower. But this is like another order of magnitude even beyond that. We're way past that in terms of what they promised us with 5G and what we are supposed to be getting with terahertz. Its photons are not energetic enough to knock electrons off atoms and molecules in human tissue, which could trigger harmful chemical reactions. But gigahertz frequency changes have been demonstrated to interact on voltage-gated calcium channels. I don't care what the people that try and rebut that and challenge that and say you're lying to Martin Paul and others that have done research on this. It was established fact decades ago. You can see both Russian and American literature where they're just openly stating these frequencies are acting on voltage-gated calcium channels, and they've tried to retroactively go back and hide that. So they're already setting the stage with terahertz frequencies that this is totally safe, which essentially necessitates people doing the same thing I did with the gigahertz frequencies, with the terahertz frequencies, to establish that this is going to be that much more scary. Again, we're going to continue on here. So they're saying the same thing. Oh, it's not like ionizing radiation. It's not dangerous. The waves also stimulate molecular and electronic motions in many materials. Highlight materials. We're looking for a more promising material in order for which to propagate these waves. And the limitation of the terahertz radiation, well, the current devices don't work for it. So we need new devices, right, that can propagate the terahertz technology. These features have been exploited in laboratory demonstrations to identify explosives, reveal hidden weapons, check for defects in tiles on the space shuttle, screen for skin cancer and tooth decay, etc., etc. The past 10 years have been the most intense work to tame and harness the power of the terahertz regime. First became part of extensive of these efforts in 2007 when I co-chaired the U.S. government panel that reviewed compact terahertz sources. The review chief's goal was to determine the state of technology. We heard from 30 R&D teams, and by the end we had a good idea of where things stood. What the review failed to do, though, was give a clear picture of the many challenges of exploiting the terahertz regimen. What I really wanted were answers to questions like what exactly are terahertz frequencies best suited for, how demanding are they to produce, control, apply, and otherwise manipulate. He says it's not really new. Since at least the 1950s, we had sought the ability to tap into its appealing characteristics. In the 70s, space scientists used far infrared sub-millimeter wave spectrometers for investigating interstellar mediums. David Leisowitz at NASA Goddard Space Flight Center, 98% of the photons released resided in the sub-millimeter and far infrared bands. Again, we might question that last name, but we'll continue on. Indeed, it's safe that the current state of terahertz technology rests in good measure on advances in radio astronomy and space science. Atmospheric attenuation poses a problem for using terahertz frequencies for long-range communication, but how big a problem? I compared different scenarios for horizontal transmission at sea level, good weather, bad weather, and a range of distances from 1 meter up to 6 kilometers, and specific frequencies between 35 gigahertz and 3 terahertz to determine how much the signal strength degrades as conditions vary. For short-range operations, that is for signals traveling 10 meters or less, the effects of the atmosphere and bad weather don't come into play. Try to send anything farther than that and you get hit with what I call the terahertz wall. No matter how much you boost the signal, essentially nothing gets through. A 1 watt signal with a frequency of 1 terahertz, for instance, will dwindle to nothing after traveling just 1 kilometer. Well, gosh, it seems like you need the right type of material and you sure need a lot of nodes because it's not going to go very far, isn't it? Well, not quite nothing. It retains about 10 to the minus 30% of its original strength. So even if you were to increase the signal's power to a ridiculously high level of, say, a petawatt, and then somehow manage to propagate it without ionizing the atmosphere in the process, again, wattages matter. Just above, he just said it's non-ionizing radiation, and you have to be more specific than that, but we'll continue on. And then somehow manage to propagate it without ionizing the atmosphere, it would be reduced to mere femtowatts by the time it reached its destination. There are no terahertz sources capable of producing anything approaching a petawatt. The closest is a free electron laser, which has an output in the low tens of megawatts and isn't exactly a field deployable device. Rain and fog will deteriorate the signal even more. Attenuation and extreme all but rules out using the terahertz region for long-range ground-based communication and radar. So all these gaseous materials, man-made molecules, etc., cause problems. Another potentially invaluable use for terahertz waves is identifying hazardous materials from afar, etc. So there's a major limitation for terahertz frequencies, and this popped up with gigahertz frequencies with the 5G, where they said, well, we're going to need a bunch of nodes because this signal degrades faster than the 4G signals do because we're decreasing the wavelength and increasing the frequency. So now on all these light poles all over your neighborhood and all over everything, there's these little nodes, some of which are very difficult to see, that are propagating 5G-based signals all over the place. And many of them were set up pre-COVID, and many of them were set up when you were locked in your home during the last lockdown. What are the problems here? We have a propagation distance problem and we have a material science problem. Research team develops a new material to convert and generate terahertz waves. This is December 18th of 2020. So they go into this discussion on terahertz waves. A German-Spanish research team has now developed a material system to generate terahertz pulses much more effectively than before. It is based on graphene, a super thin carbon sheet coated with a metallic lamellar structure. The research group presented its results in the Journal of ACS Nano. Some time ago, a team of experts working on the HZDR accelerated LB were able to show that graphene can act as a frequency multiplier. When the two-dimensional carbon is irradiated with light pulses in the low terahertz frequency range, they are converted to higher frequencies. Until now, the problem has been that extremely long input signals, which in turn could only be produced by a full-scale particle accelerator, were required to generate such terahertz pulses efficiently. This is obviously impractical for future technical applications, explained the study's author. So we looked for a material system that could work with a much less violent input with lower field strengths. For this purpose, HZDR scientists, together with colleagues from Kabbala Institute of Nanosciences and Nanotechnology and the Mainz-based Max Planck Institute, came up with a new idea. It could be enhanced enormously by coating the graphene with tiny gold lamella, which possess a fascinating property. They act like antennas that significantly amplify the incoming terahertz radiation in graphene. Literal tiny gold projections. Little alchemical projections. As a result, we get very strong fields where the graphene is exposed between the lamella. This allows us to generate terahertz pulses very efficiently. Samples were then taken to the terahertz facility where they hit the light pulses in the low terahertz range, 0.3 to 0.7 terahertz. This means that this is around 300 to 700 gigahertz that we're talking about here. During this process, the experts used special detectors to analyze how effectively the graphene coated with lamella can multiply the frequency. It worked very well. Compared to untreated graphene, much weaker impulse signals sufficed to produce a frequency multiplied signal. Just 1/10 of the original required field strength was enough to observe the frequency multiplication, and at technology-relevant low field strengths, the power of the converted terahertz pulse is more than 1,000 times stronger, thanks to the new material system. So gosh, if you had a bunch of nodes made out of graphene, you could propagate terahertz signals all over the place. And it would be more intensive in areas where you had a more dense population of said nodes. So if, let's say, there was graphene material, maybe it was even injected graphene material, let's say, and you were in a very dense population of people that had been injected with said graphene material, base material, and they're propagating these waves, that would enhance these terahertz frequencies. Even affects 5-fold, 7-fold, and even 9-fold increases in the input frequency. So, gosh, maybe, just maybe, if we had some folks that decided to get an experimental vaccine, let's say, and maybe, just maybe, there's graphene in it. And I'm not saying that there's graphene in every shot. I actually don't think there's graphene in every shot. But maybe, just maybe, a certain percentage of them have graphene in every shot. And they're having you believe that spike proteins that are leaking off of that person are infecting you, and now everybody's got these spike proteins, and we're all a self-spreading vaccine that's making everybody sick. You can go back and watch my virus isolation lectures. I didn't come to this without providing information explaining my position up to this point. So you can go back and watch my virus isolation lectures if you haven't, my 5G and COVID lectures if you haven't, so we can get to this point. Maybe the reason that you're sick around some of these folks is because they're propagating. Maybe. some of these frequencies. Now, with the COVID vaccines, there's a lot going on. I am not suggesting in any way that this is the only vector by which people that got themselves injected got sick or died. There's multiple vectors with the COVID vaccines. I covered that in some detail. We covered different lots and lethality as it related to those. We looked at different mechanisms of injury and how they might potentially function. I am fully convinced that everybody didn't get the same thing. And there's also, again, problems with people that just had somebody fill out the card and they just bought themselves a card with some initials on it, or paid a doctor to just squirt it down the drain. More and more of that with regard to these celebrities and stuff is coming out, that a lot of people didn't get these shots. A lot of these pro athletes and stuff, they just paid somebody for a card, and they don't want the NBA, the NFL, et cetera, they don't want people to know just how many athletes didn't wind up getting this thing. And if the NBA, the NFL, all these other places, if they coordinated, hey, we'll set you up with your shot, or we'll bring doctors or whatever here so you can come get their shot, you can bet which lots those shots came from, okay? They don't want to risk having their product drop like flies in the event of some of this stuff. There's many different things going on with the COVID vaccine. Nanoparticles themselves are inherently toxic. Many of the adjuvants and things like that on the product insert were toxic. I talked about a lot of those compounds back in my COVID vaccine lectures. And I also addressed that we looked at many of Moderna's patents and things of that nature, but even so, it's more likely that they're going to be hiding behind trade secrets, so there's less of an official record. So as far as the exact contents, I did show at least one example of a graphene-based vaccine based on development of some of these COVID vaccine products. But we don't know exactly what is in those individual vaccinations. There's only a select small group of people that know, and I covered how the contracts were set up by private entities to prevent FOIA requests at that time as well. The ATI company, right? Don't mistake what I'm saying here, but to ignore or deny this type of stuff, and we're going to look at just how expansive that this is foolish in my opinion, given, if you've watched my 3-part Jews, Vaccines, and Viruses lecture, how instrumental Jews have been in orchestrating this mass vaccination push and in developing the technology and being in charge of many of the industries that pushed this technology. This is not coincidental. Advances of technology in the terahertz range in neurosciences, it has been demonstrated for promising potential for biomedical applications. Way back in previous lectures, what did I talk about? I talked about the different ways people could have gotten sick during the time related to COVID. And I also mentioned the Oura ring, which spelled O-U-R, like the Ouroboros, the serpent swallowing its own tail, and the Apple Watches and all these sorts of things that are monitoring your vital signs and your sleep and your brain waves and all this kind of stuff. But at a terahertz level, you can look at complex biological systems. It has been shown to affect the nervous system. Terahertz frequencies have. Recall from the previous article, they just said terahertz frequencies aren't biologically active. Here we have in this lecture, this published paper in a medical journal, Cell, which is well regarded, them openly stating it can affect the nervous system, including the structure of nerve cell membranes, gene expression, and cytokines level. If you recall from my previous 5G and COVID lectures, I demonstrated what? I cross-pollinated the cytokine levels that were associated with being elevated and other lab values associated being with elevated with a quote-unquote COVID diagnosis, and then I supplied you with medical literature on different studies showing various frequencies showing elevated levels of those same cytokines. In about 80%, 70 to 80% cross-pollination, I would say, I was successful in finding research papers. And we also talked about how electromagnetic fields exposure could potentially result in a positive COVID test. I told you I was going to tie these ideas together. In this review, we primarily discussed the biological impacts and mechanisms of terahertz waves on the nervous system at the organism's cellular and molecular levels. They're a novel type of radiation with distinct advantages, electronic properties, non-ionizing features, etc., etc. And here they explain the bandwidths. Effect on nerve cells. Olszewskaja reported a change in cell membrane adhesion and axon structure in isolated stagnalis neurons exposed to terahertz radiation. Structural changes in the membrane, axon, and growth cone were observed after terahertz irradiating the same neurons. Biological radiation effects described above mostly occurred during the early stages of neuronal development. Neurite growth cones are primarily destroyed at later stages of neurite growth, disrupting neuronal contact. When the same neurons were used, it is found that cell death varied depending on the frequency and power density of the terahertz radiation. Cell death occurred 2 hours after irradiation with a constant frequency and exposure time. On the other hand, significantly promoted cell survival. Moreover, the terahertz radiation occurred with much lower power, improved cell survival. Tersakin applied broadband pulse terahertz radiation to the sensory ganglion of chicken embryos, found that 0.5 but not 5 and 50 power accelerated ganglion growth. Meaning what? You have the potential with some of these frequencies to cause improvements in behavior and also to induce signs of depression. You have increased aggressive behavior, reduced sleep time, increased anxiety, but you also have improvement in neurological defects. So, meaning what? Depending on what type of frequency that you're exposed to, the dose is the poison, there's all sorts of effects that could manifest themselves in individuals that have been exposed to this stuff. And we reference thermal effects, cell death, changes in neurotransmitters, accelerating nerve growth, destruction of growth cones, breaking of neural connections, changing in cell membrane adhesion. And you can think of whenever in Alzheimer's patients, they'll observe individuals that have these adhesions in their brain, these tau proteins that they're called, and you get these neurofibrillary tangles that are associated with Alzheimer's. And of course, there's this chicken and the egg debate about whether it's the cause of Alzheimer's or something's causing it. And of course, individuals with autistic-like disorders and Alzheimer's have had various studies that have shown increased levels of heavy metals in their brains. So if you have higher levels of heavy metal in your brain and you're being exposed to electromagnetic frequency, and all of a sudden those things are starting to bind and cause problems at a lower frequency, at these higher terahertz frequencies, you might not even have to have those heavy metals in your brain for this stuff to start adhering to itself. Notice these references are 2008, 2020, etc., etc. This is not 1970s literature in which we're finding this stuff. And here we're going into changes in DNA expression or changes in genetic expression. Remember way back when I talked about Jonas Salk and Survival of the Wisest, and him stating, who of course Salk was Jewish, stating that electromagnetic fields could be potentially used to accelerate human evolution, and that vaccines and things like that could be used for this purpose as well, and that we had to control basically unmitigated population growth. Where did you think this was going? Again, Helmholtz Center 2021, new materials, propagating terahertz radiation, faster mobile data, higher sensitivity. They were working on this stuff all the way through the pandemic while they were telling you that you're a moron for talking about 5G and COVID, but you're maybe kind of allowed to talk about lab leak theory, which I'm not saying that there isn't some interesting stuff about some of those labs in the Ukraine or some of those labs in Wuhan, but I don't think it's what they're trying to convince you that it is. Here's how graphene could make electronics super fast. A single layer of carbon atoms can boost signals from gigahertz to terahertz frequencies. That's right. So the 5G frequencies, which are in the gigahertz ranges now, already can be boosted to terahertz level, this level. Hey, look, differences in cortical neurons. Look, differences in cerebellar neurons, differences in cell adhesions, differences in neural structure, cell death in some cases. You can boost from the 5G gigahertz ranges, which I established again in those previous lectures, can cause loss of taste and smell, can cause shortness of breath, can cause anxiety, demonstrated in the medical literature decades ago. Those signals, if graphene is in the mix, can be upregulated to the terahertz signals, which have all these promising applications. Shuttle up to 1,000 times as much information per second. What do you think Neuralink is for? What do you think some people that think Elon is their savior for some ridiculous reason? What do you think he's there for? I'm a free speech advocate. Yes, all the conservatives will defend you for being a free speech advocate while you actively develop the thing that's going to be injected into our brains. They injected a sheet of this atom-thick material with 300 gigahertz radiation. When these electromagnetic waves hit the graphene, electrons rapidly heated, cooled off, released electromagnetic waves with frequencies up to 7 times as high as the incoming radiation. This is yet another amazing result of graphene. The 2D material has been hailed as a super material for its extraordinary abilities such as conducting electrical current. Electrical tunability of terahertz, nonlinearity in graphene. This was 2021. You were still wearing your mask when this was happening. Graphene is conceivably the most nonlinear optoelectronic material we know. Its nonlinear optical coefficients in the terahertz frequency range surpass those of other materials by many orders of magnitude. Here we show that the terahertz nonlinearity of graphene, both for ultra-short single-cycle and quasi-monochromatic multi-cycle input terahertz signals, can be efficiently controlled using electrical gating with gating voltages as low as a few volts. So the power problem that we had before, the power problem that he was saying, the truth about graphene, even in these petawatt ranges, we're not going to get enough power, now enhances power conversion efficiency by about 2 orders of magnitude. Our experimental results in quantitative agreement with a physical model of graphene nonlinearity maintained with electronic population of graphene during interaction with ultra-fast electrical fields. Our results can serve as a basis for straightforward, accurate design of devices and applications for efficient electronic signal processing in graphene at ultra-high frequencies. Extremely efficient terahertz high harmonic generation in graphene by high Dirac fermions. This is 2018. So they already knew, just making you aware, even prior to COVID, they had at least knew that this was eventually going to be able to work. In published data, who knows what DARPA is actually doing? They looked at a bandwidth below 70 gigahertz were transmitted through a single layer of graphene deposited on a silicon oxide substrate and were detected in the time domain as terahertz light wave oscillations. So there is the potential to convert this into light. And I've already talked about the optogenetics, where they're basically injecting rats and things like that with genetic modifications to different regions of their brain and exposing them to light, and it would cause the rats to engage in copulatory behavior or aggression. Fast forward to 2023, an enhanced gain of frequency reconfigurable graphene antenna in the terahertz regime. A patch antenna with a unique shape and feeding at terahertz frequency is presented. The shape of the patch can change between the 3 shapes of a triangle, rectangle, and circle, sacred geometry, and slotted patches by using the properties of graphene. In this way, by changing the shape of the patch, it is possible to simultaneously take advantage of the features of patches with different shapes in one antenna structure. The ability of changing the resonance of the frequency range of the antenna in the range of 3.8 to 5.3 terahertz. This is an alchemical process that has been in the works for centuries at this point. Let me briefly tie this back to the alchemy so we can wrap up this introduction here.
As we already established with the graphene stuff, that graphene functions very efficiently at terahertz frequencies, and in fact graphene possesses the ability to upregulate gigahertz frequencies to terahertz frequencies. And then we have this paper, Matter Manipulation with Extreme Terahertz Light, Progress in Enabling the Terahertz Technology. Terahertz light has proven to be a fine tool to probe and control quasi-particles, to drive phase transitions and association changes in material properties, and to study rotations in molecular systems, in contrast to visible light, which usually carries excessive photon energy for collective excitations. Terahertz light allows for direct coupling to low energy scale excitations of energy. The development of light sources of strong field fuse cycle terahertz pulses in the 2000s opened the door to controlled manipulations of reactions and processes. Such terahertz pulses can drive new dynamic states of matter in which materials exhibit properties entirely different from that of equilibrium. In this review, we first systematically analyzed known studies on matter manipulation with strong field fuse cycle terahertz light and outline some anticipated new results. We focus on how properties of materials can be manipulated by driving the dynamics of different excitations, and how molecules and particles can be controlled in useful ways to extreme terahertz light. So where are we headed with this? We have light and electromagnetic frequencies. I've talked about light in the form of optogenetics in the past, and how it was basically used to create fight or flight responses in rats or sexual responses in rats. And now we know, what is this terahertz light being used for? Matter manipulation. And what are the materials that are talked about? Keywords: Dirac materials and graphene. Terahertz acceleration and streaking. Optical rectification. What are we talking about here? We're talking about matter manipulation. This is alchemy. That's what this is. We've seen this association now between the usage of electromagnetic fields. We know it impacts our health. We know it impacts our thought processes. We have some control over that. We're not helpless to it, okay? Awareness with it helps. Your mindset helps. I'm not trying to go woo-woo and say, if you have cancer, it's because you have bad thoughts. That's not where I'm taking this. That's not where I'm trying to take this. But your mindset does have a more powerful impact than most people think. I'm not saying it's everything. I'm not saying if you get hit by a bus, your problem is you had a bad mindset and you should use your mind to heal yourself instead of getting emergency traumatic care. I'm not saying that. That would be dumb. But I'm saying the idea that magnetism, and electromagnetic fields are not being used directly as a part of an alchemical process by people who have Kabbalistic aspirations is untrue. It's a big part of this process, and there's a reason that it's scattered and we have to put the pieces together. But when you see a paper like this, where they're talking about direct matter manipulation by increasing frequencies into the terahertz ranges, which are ranges that, but what does graphene do? And again, you can go back and watch my COVID lectures. I don't think that there's graphene in every single shot. I'm not saying there's graphene in every single shot. We did talk about the use case for it way back when I talked about the COVID vaccines. So we're building on some of that information. But if you have this ability to upregulate gigahertz frequencies, which are in the 5G ranges, to terahertz frequencies with graphene, and in these terahertz frequencies, we know that matter manipulation is taking place, and we know that the Kabbalists want to re-engineer the world in their own image, and they have alchemical aspirations, and these have been linked to Jewish thinkers. Why do you think that they defend the electromagnetic field narrative the way that they do? Why do you think, way back when I covered the calcium ion channels, which were commonly acknowledged to be affected by electromagnetic fields in the 70s and 80s, now all of a sudden it's controversial and you're citing inferior research if you point it out. Because they knew that they would need this later. And so they get to work with their historians, they get to work with their scientists in covering up all of that information and discrediting any of the scientists that generate it, and then preventing any new scientists from doing any experiments on it. And if one of them does, just like in the transsexual lectures, they'll take to Twitter and bash that scientist for even daring to ask such a question. So when you see the same pattern over and over again in behavior, and it's defended in the exact same way, and the structure of their arguments against it are formed in the exact same way, and they stack the deck, they're not spending all of that extra effort because there's nothing to see here. They're spending all that extra effort because they know, just like with the race stuff, just like with the sexuality stuff, just like with the gender stuff, that this is essential for their goals.